Good afternoon, everyone. My name is Simran Soni. Today I am presenting a poster, and the title of my poster is Guanylene Tank Fluorescent Organic Probes for Sensing of Nitrophenolic Compounds and Zinc 2 Positive Ions at the ppb level. The author of this poster are Dr. Gauri Chakraborty, Dr. Prasenji Das, and Professor Sanjay K. Mandal. In this research paper, in this researchers synthesized two new sensors and with a variation in their spacer group. In the first one sensor, the spacer group is flexible tetramethylene, and in the second one, the spacer group is semi-rigid xylene. And with the change of this spacer group, the effect was investigated towards the sensing of nitrophenolic compounds, especially highly explosive 2,4,6 dinitrophenol compounds, in comparison to other nitrophenol compounds like 2,4-dinitrophenol or 4-nitrophenols. And also, the effect of flexible and semi-rigid spacers in this organic process was further established by metal ion sensing. Metal ion sensing where 1 and 2 displayed selective sensing for zinc 2 positive ions. The idea behind the investigation, the idea behind the development of these two new sensors for is to detect the lethal nitroaromatic compounds. No doubt, nowadays single molecular sensors have been a key research activity for detecting these lethal nitroaromatic compounds, which harms the environment or because of its highly explosive, but the selective and sensitive detection of TNP in aqueous medium is strongly required. No doubt, there are a number of sensors. There are a number of sensors that have been utilized for TNP detection, but TNP and small molecule detection, but like polymers, macromolecules, and synthetic probes, etc. But these all show high sensing ability in dimethylformamide, dichloromethane, and tetrahydrofurane. No such sensor is there that show highly selective sensing ability in water. Thus, fluorescent materials with high stability in water for detection of nitrophenolic compounds are strongly required. And for this, fluorescent material is the best in comparison to other materials, and because it is highly cost effective. Moreover, it's give timely response. And the detection of electron deficient nitroaromatic compounds is by different signaling mechanism. It is like photo-induced electron transfer mechanism, or others like RE resonance energy transfer mechanism. Researchers synthesized these two sensors by the combination of the shape-based chemistry and the nucleophilic substitution reaction. And this concluded that this is a two-step reaction, and both are two-step reaction, and they give a very good yield. The first sensor has 98% yield, whereas second has 92% yield. And if after the synthesis of this, they utilized it for further studies. And what they noted, first of all, they noted the solid state emission spectra of both the 1 and 2. And what they noted that the emission wavelength, first peak show emission wavelength at 428 nanometer, whereas second shows two peaks and two wavelength. One is at 449 nanometer, second one is at 553 nanometer. And after this, the reason behind the low intensity of second one, the reason behind the broad spectra of the second sensor in comparison to first. The reason is the low intensity reason is because of the self quenching, and the broad spectra reason is the formation of the excimer because in second there is a presence of a xylene group, and they have the capability to form pi interactions. As a result, this self aggregation quenching, and due to which they form the broad spectrum or at higher wavelength. Further, to check the effect of the solvent, researchers noted the emission spectra. What they did, they took different solvents like DMSO, DMF, chloroform, methanol, so on, ethanol and water, and they added 1 milligram of the sensor in 2 milliliter of different solvent, and they noted the emission spectra, and they observed that the sensor in water show high intensity peak. This is just because that the sensor is insoluble in the water, and as a result the sensor aggregate, and as a result they induce emission. This is known as aggregation induced emission. This high peak is because of aggregation induced emission in both the sensor 1 and sensor 2, whereas others show the low intensity or also show little bit high wavelength in comparison to water peak. This is just because of the solubility effect of the different solvents. To further demonstrate the aggregation induced emission, researchers took different volume fractions of the water, And what the different volume fractions of water in 32 micromolar solution solution of THF, and they noted the emission spectrum, and they observed that the higher fractions of the water, the intensity is maximum. At this point, it is proof that there is a aggregate. This intensity is because of aggregation induced emission. Now, to check the now later on, researchers also performed one also noted the one spectra, and what they did that the change in the emission intensity percentage after addition of nitrobenzene. What they did that in this solution, that 32 micromolar THF solution, they added nitrobenzene, and after adding nitrobenzene, they noted that the emission intensity is decreased at a high extent in both the sensors, sensor 1 and sensor 2. Emission intensity is highly decreased in comparison to normal solution. This is from this point from this they have the curiosity to check the effect of the nitro compounds. But before the checking the effect of the trinitrophenol and other nitrophenolic compounds, they record this spectra, because in further studies they contain the water as a solvent. So they first check the excitation spectra dispersed into milliliter milk water, purified water. And what they observe that they observe that they show the broad spectra in comparison to solid state diffuse reflectance spectra. There is a not much difference. There the shape is the same. The difference is only the broad spectra. This is due to the polar effect of the water, and as a water is polar, so there is a the gap between the highest occupied molecular orbital and lowest unoccupied molecular orbital is low, and as a result the high wavelength. This is After that, researchers noted the effect on the emission spectra of 1 and 2 dispersed in millicube water. What they did, they performed noted the emission spectra. First, they considered 2 milliliter of water and added 1 milligram of sensor in 2 milliliter of water. And after that, they added volume fraction of the trinitrophenol, 2,4,6 trinitrophenol, from 0 microliter to 200 microliter, and noted the emission spectra. And what they observed that there is a bathochromic shift of 70 nanometer in first sensor, and second one there is a 21 nanometer bathochromic shift. And this shift in bathochromic shift, or say the red shift, is just because of the energy transfer between two opposite group, that is electron deficient group, that is 2,4,6 nitrophenol, and electron group rich group, that is our sensors are electron rich. This is just because of energy transfer, and they upon different increment different addition of the trinitrophenol, obviously there is the different rate of quenching. To check the quenching, what they do, they calculate the quenching percentage by using equation, where they observe that when we add a TNP, trinitrophenol, and then there is a maximum quenching, and this quenching is just because of energy transfer. And they inform the first and second. The second show major quench second show higher quenching in comparison to first sensor. And for further investigation, they noted they took the pic, and what they did in this first row, there is a normal 1 milligram of sensor in 2 milliliter of water, but in second there is an addition of the nitrophenolic groups, like in this 2,4,6 trinitrophenol and 2,4-dinitrophenol, 4-nitrophenol, like this. And what they observe that the A shows the different quenching, the A shows different fluorescence in comparison to other. And what from this it is clear that xylene play a major role in the quench. To check the principle behind the selective detection of TNP, researchers check the mechanism, and for that they check the first quenching constant. They check the quenching constant by using the Stern-Volmer equation. And what they did, they plotted different graphs between this intensity ratio and the concentration, and they observed that at higher concentration there is upward band curve, whereas at lower concentration there is a linear curve. This is just the upward bend curve is just because of the energy transfer between the two opposite groups, that is the electron deficient trinitrophenol electron deficient, and whereas sensor are electron rich. The upward bend curve is just because of this. And among these two sensors, they also noted that the second one shows the higher quenching constant in comparison to first. This is again because of the presence of the xylene group. And from this, they check that yes, this xylene plays a major role because they have the high quenching constant in comparison to the first. Later on, they also check the detection of limit, and they noted that the first one shows a detection limit of 1.2 ppm, whereas second shows a good limit of detection that is 0.3 ppm, and that is highly selective. And later on, they also for further investigation of this mechanism of action of TNP detection, they performed the spectral overlap absorption spectra of different nitroaromatic compounds and emission spectra of 1 and 2 dispersed in water. What they did, that they noted the spectra, and but this is normalized intensity spectra, and they observed, and we know that the maximum overlap is, as a result, there is a resonance electron transfer. And they noted that the trinitrophenol shows the maximum overlapping, and due to this maximum overlapping is just because of the more resonance electron transfer, and in comparison to 2,4-dinitrophenol and 4-nitrophenol. And from here it is clear that in quenching, resonance electron transfer also plays a role. After that, they also performed another mechanism, quenching mechanism, that it is via photo-induced electron transfer. Before that, we performed a mechanism that is by resonance electron transfer, and it is via photo-induced electron transfer. And in this, it is clear that the lower the energy of the lumen, higher more the quenching. It is just this. And after that, they also noted that the trinitrophenol and 4-dinitrophenol and 4-nitrophenol, they noted this homolumo gap between these. And what they they observed that the homolumo gap between trinitrophenol is low in comparison to other. As a result, the greater quenching, because the low homolumo gap, the higher the wavelength, and as a result, there is a greater quenching. Also, as we know, in comparison to first and second shows the more quenching. This is because the low energy of the luma in comparison to one, and as a result, they also again the energy gap is less, and they shows a higher quenching. And also, furthermore, the possible mechanism of TNP sensing is proved here, that in the first one, there is a hydrogen bonding of the nitrogen of the pyridine and quinoline between the hydroxyl group of the trinitrophenol, where in the both sides, whereas in the second, there is also another third thing, that is electron transfer. This is there is electron transfer from xylene group to trinitrophenol, as xylene is electron rich and trinitrophenol is electron withdrawing. Just because of this electron transfer, and that is not present in the first one, in this second it shows some more quenching in comparison to first. And here it is proved that xylene, the second sensor is the second sensor is more accurate in comparison to first. But the demonstrate the role of the xylene. In this, the previous mechanism can be proved by this TML03 module. In this module, what the researchers saw, that there is the interactions, and in this is a sensor 1, this is sensor 2, and in this sensor 1, there is a hydrogen bonding between the hydroxyl group and hydroxyl group of 2,4,6 nitrophenol, and the nitrogen of the pyridine and quinoline, and same as a second. And whereas in the third, in this third picture, they shows that this interaction is between the xylene group of the sensor and the hydrogen xylene group of the sensor, and the 2,4,6 nitro and this 2,4,6 nitrophenol. They show the interaction between xylene and 2,4,6 trinitrophenol. And here it is proved that there is a photo-induced electron transfer. And from up to this studies, it is clear that the TNP shows a highly selective sensing, that the sensor is highly selective sensing for TNP. And then they performed the selectivity test. In the selectivity test, what they did, that in this blue bar represents the 1 milligram of sensor in 2 milliliter of water, whereas this red bar shows the addition of different nitroaromatic compounds, and in third show the TNP. And it is clear that the TNP shows a high selectivity among others, no doubt. These other aromatic compounds also show a sensing ability, but they are not highly selective, show selectivity from that is moderate to slight, but this is the large extent, but this shows a large extent of selectivity later on. And then this sensor is utilized for practical applications, on-site detection of TNP for practical application. In this research, what they did, they took the prepared the strips and they added a drop of different nitrophenols on different strips, and they observed that the for TNP, the dark blue spot was show there is a dark black blue spots for TNP. And then what they did, they took the TNP and then added took the different concentration of TNP, and for both the sensor 1 and sensor 2, and added a drop of these and added a drop of this TNP on the different strips. And they observed that for the second they show the dark blue spots in more blue spots or dark blue spots in comparison to first and second. They also observed that from at the concentration of 10 raised to power minus 6 in second sensor, at the concentration of 10 raised to power minus 6, they start to show dark black spots in comparison to first. And from it is clear that the TNP is used for practical applications. This sensor is used for practical applications, and later on they also perform this sensing mechanism. As we know, this is all this as we know that this sensor is also sensitive for selective sense is also utilized for selective sensing of metal ions. What they performed the experiment. What they performed, they took the different metal ions and they noted that the sensor is highly selective for zinc to positive metal, followed by cadmium. This followed by because of the chelation enhanced emission. And they later on also noted that the binding affinity of the zinc to positive ion with the nitrogen of pyridine and quinoline is more. Quinoline is more, due to which it is highly selective. Zinc is highly selective for these sensors. And what they noted, they performed the titration experiment, and from this they noted the limit of detection. For first one, it is the 5 parts. They noted limit of detection in parts per billion, and they noted that for first one there is a 5 parts per billion limit of detection, whereas second 10 parts per billion in limit of detection, and it is the highly better limit of detection in comparison to other sensor that was reported previously. And also they show the adapts of this. There's a 1:1 adapt and this is 1:2 adapts. And what they did, that in this, because of tetramethyl flexible methylene group, zinc is highly surrounded by this end, whereas in this it is not possible. And it is because in second, because of the presence of the this semi-resilient, this adapt is not possible. And in conclusion, it is clear that the two new sensors based on quinoline and pyridine groups with variation in spacer from tetramethylene in 1 to xylene in 2 have been seen successfully developed and synthesized. And by utilization of various techniques, it is evident that the photo-induced electron transfer, energy transfer, electrostatic interaction, and resonance energy transfer play an important role in sensing of TNP. Also, the metal ion sensing experiments reveal that emission intensity of 1 and 2 was selectivity enhanced by zinc to positive ions compared to other metal ions, resulting in formation of 1:1 adduct and 1:2 adducts respectively. Thank you. This is my presentation.